In fire heater, one of the most important control is coil outlet temperature control. In this particular lecture, we are going to discuss about the mechanism how the coil outlet temperature is controlled. In this particular lecture, we are basically going to focus on the fuel side control. So, as you know, in a fired heater, if fuel is mixed with air and this mixture of fuel and air are burned inside the heater, and this heat gets absorbed by the product, and in this process product gets heated. Now the temperature of the product at the outlet is very crucial for the downstream process, and that's why this temperature needs to be controlled. Now, how this temperature can be controlled? As you know that this temperature will depend on how the fuel is burning, right? And the fuel burning temperature depends on two things. One is fuel and another is air. Obviously, there is another parameter, that is calorific value of the fuel. For the time being, let's consider that the fuel that are going into this particular fire heater is always the same kind of fuel. So we don't need to worry about the molecular weight or the calorific value of the fuel. So the temperature of the coil outlet can be controlled in two ways. Another is by controlling the fuel, the amount of fuel that is going inside the burner, and amount of air that is going into the burner. Again, air composition also matters in this temperature. Normal air contains around 20.68% of oxygen. If we can increase the oxygen content by additional introduction of oxygen, then this temperature can rise up for the same volume of the air. So, but for initial case or for this lecture, we will consider we are using normal atmospheric air and the fuel molecular weight is constant. Molecular weight is constant and the air contains around 26.28% of oxygen, right? Now, the temperature, how the temperature can be controlled? The simple mechanism is you measure the temperature and the coil outlet and feed it back to a closed loop controller, which is denoted by a TC here, and then the TC take action depending on how the temperature increases or decreases by closing or opening the fuel gas valves. As you can see, there are two fuel gas valves that are kept in parallel here. One size is a bigger size and another size will be smaller. So that is used to increase the turn down ratio of the combination so that both startup, normal operation and shutdown can be covered. Also, there may be cases that there may be multiple burner, right? There is not a single burner, there is multiple burner, and sometimes two burner is operating, sometimes three burners is operating, sometimes maybe if there are four burners, all four burners are operating. So the amount of fuel that needs to go varies, right? Depending on the number of burners that are working and the how much load each burner is or each burner is having, right? So, so maybe that is very difficult to achieve by using a single control valve. That's why two control valves are normally taken in parallel. Size of one control valve is obviously bigger than another control valve. Okay, so back to the temperature control. Okay, so temperature control, the temperature will be measured and the measured temperature will go to the temperature controller. So temperature is here PV, and there will be a MB that is provided by the temperature controller, and there will be set point that will be given by the operator. Okay, so depending on the set point and the PV value, the temperature controller will give the open or close command to the valve to regulate the flow. And by regulating the flow, the temperature or the combustion is gets controlled, and in that way temperature gets controlled. Now this process, as you can understand, temperature is very slow process, right? So by the time you cut the fuel by closing the valve to the decrease of the temperature, it takes sufficient amount of time, right? So, so in this slow process, then efficiency cannot be achieved, or there will be high excursion about the set point, right? You cannot be able to achieve the set point. There will be oscillatory thing about the set point, because by the time you are closing the valve, temperature may have increased. Then again, you want to decrease the temperature, right? And for decreasing the temperature, what you will do? You will close the valve, right? Then again, opening, closing of the valve, and along with that, the cycling of the temperature will occur. So you will, it will be very difficult to reach at a steady state. So what is the solution? Solution is to use some parameter which will be more, which will respond faster than the temperature. And as you can see here, there are two parameters that gets easily affected by opening and closing of the valve. There is the pressure downstream of the valve and the flow that is going through the line. So when you are opening and closing the valve, this pressure and this flow gets changed readily, right? So you can use this pressure and flow as a secondary variable to control the temperature, right? So there are two secondary variables that we can think of. One is the pressure and another is the flow, right? Now how that control can be achieved? So if we are using the flow control, the temperature controller will be the primary controller, and it will give the set point to the flow controller, or set value to the flow controller, and the primary controller set value will be given by the operator. Okay, so the TT is giving the PB and it is generating the MB. The MB acts as a SB to the secondary controller, and the secondary controller gets process variable from the from the flow transmitter, and depending on the set value and this PV, it will generate an output to regulate these two valves. And in this way, what will happen is, if there is a disturbance in the flow, it will get easily acted on by these two valves, right? So this is how it avoids the variation or cycling in the temperature output, or sluggishness in the temperature control. Another option is to use the pressure control. So there is a pressure transmitter. So again, the TC will be the primary controller and the pressure controller will be the secondary controller. So TT will give output, and this output will be the PV, will act as the PV to the temperature controller. Okay, and temperature controller output is MV, and there will be a set point given by the operator. Okay, and this MB will act as a set value to PC, and the PC will get the PV from the PT, and it will generate the MB. And this MB will control this to fuel gas valve, right? And in that way, if there is a variation in the fuel flow, that will be taken care of without disturbing the coil outlet temperature. Okay, now which one we need to use? Whether we should use fuel pressure control or we should use fuel flow control. So as per API, when we use the flow control, if we add another burner, so this you see there are these two control valves are there, right? These two control valves are there in parallel, and then there is a pressure transmitter here, and after the pressure transmitter there are number of burner. There can be burner 1, burner 2, burner 3, like that. 1, 2, 3, 4, right? And there will be again there is a flow transmitter here, right? Now when pressure control, adding another burner, say suppose at a time this burner 1 and burner 2 are going on, and burner 3 and burner 4 are off, right? So if you try to on burner 3 also, then there will be the gas will go inside, right? Burner 3. So what will happen? The pressure will reduce, right? So when the pressure will reduce, the, what it will try to keep the temperature constant, it will try to more flow, right? And as the more flow occurs, there can be a chances of temperature spike. On the other hand, with the flow control, when adding a burner, the pressure will drop, right? And potentially causing a heater trip or low burner pressure. So this is how you can think whether you need to choose a pressure control or flow control. In the coming lecture, we will be discussing more about the merits and demerits of using pressure control and flow control, and at the same time, we will be discussing about the air side of the temperature control.